Welcome, everybody. It's great to have you here, and we're very excited to have Trey Farmer and Nikki Kruger join us tonight for Construction Tech Tuesday. So Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and elevate the work and programming of the Passive House movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce Construction Tech Tuesday to share the technique and the technology of passive house construction tech. Each week, we welcome guest practitioners to dive into the details of practice with a builder and tradesperson as our target audience. And we welcome folks from all corners of the construction and design world to join us each week. And this week, I want to give a special shout out to our sponsor of the week, StoCorp. StoCorp is a founding sponsor of Passive House Accelerator, and they're providing special support this week to support the podcast, Construction Tech Tuesday, and the Global Passive House Happy Hour. So with that, I will hand it off to our esteemed co-hosts.
Thanks, Zach. Welcome to another week of Construction Tech Tuesday. We have an exciting pair of presenters presenting about dehumidification and how to build passive house down in the southern Texas area. Austin, one of my favorite cities down south. Can't wait to get back into regular mode and go see some live music in Austin. So these guys, their presentation last night was music to my ears, talking about building science, dehumidification, mechanical systems that work, and everything that makes sense to me. So I'll quit talking and pass the mic to my other presenters.
I'm Shannon Pendleton, designer and passive house consultant at Sanderson Design. I'm excited for tonight. Welcome, everybody. I'm coming from the East Coast in New Hope, Pennsylvania. And after last night's pre-show, I'm ready to keep my sensible and latent load straight and my manual J handy. What are you looking forward to, Sean?
Absolutely. Well, I have to go back a little bit because I finally had time. I was away about a month ago. It was my birthday, and Ed May and Amy were on, and Ed May talked about the craft. And he talked about purpose, mastery, and autonomy. And in my craft, I have to say the mechanical part is an area that I definitely need to improve on. And so I'm happy that Nick and Trey here are to provide us with a lot of knowledge that I typically deal with, tapes and membranes installation, and I don't always dive into the mechanical stuff. So I'm really looking forward to this presentation where I can learn more. And as you said, we've got good stuff coming. So Mark, over to you, wherever you're located in the world today.
Thank you, Sean, Kevin, Shannon. My name is Mark Willey. I'm thrilled with tonight's topic. Taking on the Passive House project in Texas is no easy feat. So Trey brings us his experience from forge craft, architecture, and design, all the way from 2016 to now. And from 2010 to now, Nikki Kruger brings us her expertise from Thermostor. And I welcome Trey and Nikki to introduce yourselves and begin the presentation.
All righty. I'm going to start us off with a overview of the house and then hand it off to Nikki, and we can get into the really good stuff. So this is my house. We've owned it, been in it for about 10 years. A couple years ago, decided to do a addition, deep energy retrofit, turn it into a passive house. It's about a mile west of downtown Austin. See our little PV array there and the modern addition to the back. That's what it looked like before the house. It was 1914, no insulation anywhere, original windows. You could see sunlight through the floors if the light was shining the right direction. We blew a 16 ACH before we started tearing things up. So pretty big difference now. A little bit more than a 16 ACH at this point. So our assembly is a 2x6 wall. We've got a rock wool bat insulation in the roof and the walls, and then we use the Zip R6 system for our walls. So part of what we were doing down here was, sort of first in market. We hosted a lot of building education days for the design community and the build community. And we really wanted to use products and techniques that were very familiar, even in the spec market down here, just, show that this is not, you need to think about passive house. It's not an easy thing, but it's possible. So we loved working with the Zip. Created some really easy details, especially with the historic renovation. We got down to about 1 ACH using Sweat and Pookie. And after about a week with no change on the blower door, we were just running it constantly. Our builders kind of threw up their hands and told us to call our friends over at Aero Barrier, and they got us down to about 0.4 ACH. We certified under the 2018 FIAS pilot. We're a FIAS 2018 pilot project, so it's actually the 0.05 CFM for envelope, but for our size of house, they're actually like very, very close in terms of the CFM per envelope limit and the ACH. One of the events we did was a lot of fun. We hosted a happy hour. This is one of my mentors, so we'll talk about it a little later. Keith Simon, who's a professor and architect and envelope expert down here. And we bought the biggest fog machine we could get at Rock and Roll Rentals, filled the house up with smoke, and then positively pressurized it. And it was great. We saw a bunch of like little teeny tiny leaks here and there. And then we had one big framing leak here where we had sort of like a 4 inch by 4 inch hole up at this modern roof detail that we missed. And it was just billowing smoke out of here. So it was really fun to see, great to show people exactly what airtightness is all about and how, just really brings it home when you can actually see the leakage. There's a floor plan. We added about 50% to the back. We've got downtown views. So we've really, kind of overglazed on the east side, but we have a huge overhang in the screen porch that really helps shade that southeastern side. And then the kind of rework the floor plan, but the exterior is all original, sort of rebuilt in place. So we have tri-pane Marvin clad windows that are sort of faux double hung to match the old double hung on the old house, and then we have a more modern window take on the new part. Yeah, one of the things just with passive house that we love is like being able to also be outside. People are always asking us if we can open up our windows and doors, and so we have a screen porch that out here we have some really great shoulder seasons, and so we can just open the door up and have this nice sort of extended house without getting all the bugs. Another thing that, as everyone on this call is familiar with, insulate up at the attic line, but one of the fun benefits of that is you get to use all that space, and I think pitching that to our community as an asset as opposed to something weird to do, not just from like a mechanical and an envelope standpoint, but, we were able to capture a nice loft up here within the existing roof line that was just kind of like a rat house before, 140 degrees in the summer. And now this is like one of the coolest rooms in the house with this loft over it. Also, we get to drop in some great, really play with that interstitial space, drop in some daylight, into the kitchen. And really is the heart of the house, and it's because we moved our envelope out to the exterior. And then we've got another skylight in the shower because architects have to do that in all the showers, which I know Nikki and other mechanical experts are like, what are you doing? But it looks so good and it's fun. And I get to look at the moon when I take a shower. So it's worth it. And we get to have this monster mechanical room up there. This is sort of the other half of that loft space. And if you give your mechanical sub a space like this, he's gonna love you forever. So we'll get into the details on this a little later. But we got our IQ Air MERV 16 filter, our Mitsubishi VRF, and then our DHU up here, and then the ERV is just off screen to the left. We worked with Positive Energy. They're a great crew, local, but they work all over the country. They design mechanical systems and make sure all your loads are perfect, make sure you're not having structural conflicts, making sure you're not getting hot or cool stuff in the wrong place. But especially in a project like this, it's kind of first to market. Passive House. We really wanted to make sure we had all our bases covered, and it was awesome having them on board. And plus, we get this great graphic and have a 3D model of our HVAC system, which is pretty awesome, or at least I think so. Range hood, cooking exhaust. We vented our exhaust hood, which I know is a sort of a perennial question of whether or not you should vent your exhaust hood in a Passive House. You know, it's a you know, you get into all sorts of barrier pressurization issues. It's been an ongoing sort of question for us on projects, but we decided to vent, and we have a filtered makeup air system that basically puts a hole in the house whenever we cook. And you know, we cook quite a bit, especially with COVID, being home so much. My wife's a chef turned interior designer, so it's great to be able to get all that stuff out. If you want to do a deeper dive on the mechanicals, I mean, we're gonna get into a lot of this stuff, but Matt Reisinger and Miguel Walker from Positive Energy spent about half an hour up in our attic talking about it in depth. It's a really great video on there, and it's one of the links that's posted. But they do a real great deep dive into all of it. I'm not really going to talk about this stuff too much, but maybe for questions later, we did have a nice article we posted about the way the house performed in that deep freeze. We had no power for 3 days. It was really interesting as a case study, you know, living in it with my family and having our neighbors be in houses that were identical to what this house was before we did the Passive House retrofit, and just watching the performance in a 1914 house with no insulation versus a Passive House. And this is my team, Forgecraft Architecture. We do sort of all scale of stuff and love getting geeky with you guys and doing passive houses and affordable housing, custom homes, all sorts of stuff. So I'm going to hand it over to Nikki now.
I had the pleasure of actually working with Trey, providing some dehumidification to his existing home before they did the renovation because they were having some moisture issues. So we actually provided him that Ultra Air 70 that you saw there to do some dehumidification until they got the whole system going. But there's a real need for dehumidification as our homes become tighter and tighter. We have comfort, health, and property protection. And I'm sure in the last year, we've all been inundated with ventilation and filtration and moisture recommendations, but really controlling humidity is vital for our health. There's a lot of partial and no load times of the year, especially the tighter our homes get. We can't control how people live in homes. We can design it to precisely how we think it should be run, but nobody's going to run it that way. And really, it's the only way to ensure 50% relative humidity all the time. So just some terms and definitions. A pint's a pound the world around. I started thinking about this a little bit more when Mark and I were going through this yesterday. I'm like, well, if we do have anybody from across the pond, a pint is probably not a pound. Unless you're hitting a really good happy hour. But in terms of dehumidification, a pint's a pound the world around. It takes approximately 1,054 BTUs to remove 1 pint of water. And that's really important when we start getting into tighter homes because we're generating heat to remove moisture. So we might have to think about the design and the layout of that system a little bit more. And then 1 CFM out is 1 CFM in. I know that these are two super tight house. I know Trey's house is super tight, but the reality is there's some infiltration. And if we're running negative, that means we're pulling in from the outside, and we got to think about where that infiltration is and where that moisture potentially could be hitting. So just so everybody understands what a whole house ventilating dehumidifier is, it is a dehumidifier that is designed to integrate with the HVAC system. You can bring in outdoor ventilation air to supply, it's a positive pressure. Obviously in passive houses, we're using HRVs and ERVs, and the dehumidifier is usually standalone. We have MERV 13 filtration in our dehumidifiers. So not only is the ventilation air getting really good filtration, but also anytime that dehumidifier works, the air in the house is getting good filtration as well. So that is integrated as part. So the AC runs, we remove moisture, the AC shuts off, there's still moisture in the air, the dehumidifier comes on. Or if you're in shoulder seasons and you've got high dew points outside, The dehumidifier then will help take care of that moisture because obviously your air conditioning is not running. So two terms that I want to just make sure that we're all on the same page with is latent moisture and then sensible. So sensible is what your thermostat is on the wall, hot or cold. You're uncomfortable, you go over, you crank on that thermostat, and that's sensible. And latent is the moisture in the air. And the ideal situation is to make sure that our air conditioning is set up to remove as much moisture as possible when it's running, and then to have a backup like a dehumidifier when it's not. And a lot of times I get comments that, oh, well, Trey lives in Austin, Texas. Of course he needs a dehumidifier. It's humid there. But the reality is, as we look at a dew point map here, and this was a late September dew point map, you can see basically anywhere that it's starting from that yellow to orange. We call these green grass climates. And typically you're going to need some sort of dehumidification in these climates. If you're down south and you're in a leakier house, your air conditioning is going to run a lot and it's going to remove a lot of moisture. But as we get tighter in humid climates, the air conditioning, the whole goal is for it not to run as much. So you still have to have something to deal with the moisture. But even if you go all the way up to Maine, we got 70-degree dew points in September. We're not running air conditioning. And the reality is those 70-degree dew points in the spring and fall, and even in the summer, can last for longer periods than they used to as we go north. And we don't have the temperatures to run the air conditioning to deal with those. So this dew point map is from one of my mentors, Ken Gehring. And he puts these together and sends them out to us. And basically he said, you know, in this area where you're seeing the orange, if you want 75 degrees and 50% relative humidity in your home and you're ventilating with 100 CFM, you're going to need 1 to 6 pints of dehumidification an hour. So you got to figure out how you're going to control that moisture for that 50% RH in our homes. So this is a dew point calculator that I use quite a bit in my trainings, and it's free. It's on dpcalc.org, and I can type that into the chat later, unless Shannon, you can do it, but it's dpcalc.org. And what you can do is basically I took in a dew point from that map, put in a more mild temperature where we're not running air conditioning. And you can see over here on the right-hand side, the mold risk. We got a potential mold risk in 5 days. So obviously microbial growth is a word none of us want to hear in our homes whatsoever. So that's the worst case. But really what we're trying to provide is comfort and ensured healthy homes to people. And so when we're thinking about moisture, we constantly have to be thinking about how are we going to control it, no matter what's going on outside or what they're doing inside. Now, you know, I've had people come up to me who are growing things in their basement in Michigan and shouldn't be. That's a whole different scenario, or they should be. I'm not one to judge, but we're talking about normal living behavior kind of stuff. So people, every person generates about 1/2 pound of moisture per hour. We have seen a huge increase in our sales in the last year because everybody was home. We were homeschooling, we were working from home, we were cooking more because we couldn't go out to eat. Everybody was cleaning because that's what we had control of, was our homes. So we need to, you know, we're living there, we're generating moisture. How are we going to deal? We can stop as much moisture as we want coming from the outside, or try to, with our envelopes. But then what about the moisture that's being generated inside? So about 4 people in a home is about 2 pounds of moisture per hour. And again, a pint's a pound the world around. So Lisa White put this slide together a couple of years ago. We spoke, and I unfortunately missed the presentation, but was part of the original presentation on dehumidification with passive houses. And this was titled Advances in Low Load Homes. And the reality, it's advances in low sensible load homes. We are we are minimizing the amount of runtime on our HVAC systems due to a temperature on the wall, but it's not based on the moisture in the house. So continuous insulation, airtight construction, better windows. Of course, mechanical ventilation is going to affect our sensible and our latent. If it's high dew points outside, wet outside, we're going to have to bring that in. We're going to have to deal with it. And then ducts and conditioned spaces is driving down those cooling loads as well. And ducts and conditioned spaces means less runtime on an AC because you're not losing 30% of your leaky ducts to the outside, which means you're going to get less latent removal or water from your AC as well. The bullseye for manual J for cooling is 75 degrees and 50% relative humidity. So manual J is a guide or manual from ACA, which is the Air Conditioning Contractors of America, and the software that HVAC contractors, mechanical engineers are using to size the HVAC equipment. And then manual S is what they use to pick out the equipment for the job. So manual J, which we need to know in the passive house industry, automatically oversizes the HVAC equipment or loads by 15%. So then what happens is the HVAC contractor takes what the manual J is spitting out and says, I don't want 300 people calling me on July 4th when they have 20 people over at their house and that HVAC system can't keep up. So then they oversize it a little bit more, which means that in normal situations, you're hitting a peak load in August when everybody just in your family's home, it's going to come on and get to that thermostat temperature really quickly and going to shut off. And you're not going to get the runtime that you need from that HVAC system to actually have water going down the drain. So you need about 20 minutes to really start getting water removal from your HVAC system. Half hour is ideal to really get water going down the drain, but you got to remember those coils got to load and then they got to collect water and then they got to start dripping and going down the drain. And that takes some time. And this manual J, what you need to understand is for peak load conditions. So most of the country, these peak load conditions are 1% of the year. So we got to think about how we're going to control moisture the rest of the time when we're not running at peak load conditions. So this is a chart, a slide that a good friend of ours, Mike Barsick from South Face, put together. And basically what he's showing here is that the manual J design temperature for Atlanta, Georgia is 92 degrees. So that's what they're going to put in the manual J as the peak design load is 92 degrees. While ASHRAE humidity design based on moisture is 82 degrees. That's a huge difference. That's a 10-degree outdoor difference of running at peak load or running partial load, really. And then up here, they put together the bin temperatures. So here you're seeing the temperatures across the top and the number of hours of occurrence that those temperatures happen. So, I mean, really, you take 80. You're in a tight house. I mean, you're not running a lot of air conditioning at peak load in a passive house. Hardly ever in Atlanta, Georgia, if everything's been done correctly. So how are we going to control the moisture? We know we can keep the comfort with the temperature with just a little bit of AC, but how are we going to manage the moisture from the ventilation and from the people? So the ultimate goal of every energy efficient building standard program is to run the largest system in the house as little as possible to save energy. But the result is we've got more efficient, sensible cooling at the expense of latent removal. So we can get to that temperature quick, but we're not getting the water out of the air. We have really energy efficient HVAC equipment that, again, the higher the SEER, it's really efficient at getting to that temperature. And then we're seeing a lot of partial to no load on AC systems like Trey's house in hot, humid climates. So one thing that I'm really advocating for in the industry is learning more about the sensible heat ratios of our AC equipment. And basically, that is the dehumidification effectiveness of that air conditioning equipment. And what that looks like, this is data from a ducted mini split manufacturer. And you can see here, we've got a 14 SEER system. So basically run of the mill anymore. And over here, the sensible heat factor of this equipment is 0.62. That means 62% of the BTUs are going to sensible cooling, get into that temperature, and 38% are focused on water removal. So that means when this is running for an extended period of time, you're getting really good water removal from this piece of equipment. Now, of course, we're seeing more and more ductless mini splits going in with really high SEERs. And this one here, this is a half-ton ductless mini split. 96% of the BTUs of this equipment is going to sensible, and you're getting 4% on latent. So if my pen shows up that's the size of a condensate line on a ductless mini split, is about the size of a pen or a pencil. And the reason being is they just don't remove a lot of water. So variable capacity equipment, hear this all the time. I don't need a dehumidifier, we're using variable speed equipment. Well, the reality is that equipment still is very focused on a temperature, and it's not getting as cold on the output of the coils that regular equipment does. So it has a higher operational sensible heat ratio. And still, when it is running, 1/3 of the BTUs are going to sensible, and or 2/3 of the BTUs are going to sensible, and only 1/3 to latent. So you're still not getting the moisture removal that you potentially need. And one speed of variable is off. So if it's 70 and raining out, the homeowner is not running air conditioning to control moisture. They're walking by a register and feeling cold air. They're going to shut it off. So we've got this great app out there. Anybody can download it. It's Ultra Air Psychrometric Calculator. And what you can do with this is basically you can put in your inlet conditions. So whatever it is outside, whatever the conditions are outside, you put in here, and the outlet is what you want it to be inside. So I always try to get around that 55-degree dew point, because that's what ASHRAE recommends for our dew points inside. And then I took a flow, which is my ventilation rate of 100 CFM. And this tells me, based on ventilation rate alone, how much, oh no, sorry, how much dehumidification I'm going to need just based on ventilation. And then I have to take into account the people. So I got to add the people load to this, and this gives me the moisture load of that house. And then I've got to decide, okay, at 85 degrees partial loads in a hot, humid climate in a passive house, how much air conditioning am I running? And how much supplemental dehumidification am I going to need? And then here we have 70 in rating. So we have no heating or cooling going on. Same kind of scenario, 100 CFM. I've got 90 pints of dehumidification just based on ventilation, and then the people, how am I going to deal with it? So it's a really great app. I use it a lot just to figure out dew points, because what's important is somebody can call me and say, my crawl space is 70% relative humidity. My first question is going to be, well, what's the temperature? Oh, well, it's 38 degrees outside. Okay, well, then let's figure out that dew point. Oh, the dew point is super low. There's not much water in the air. So the dew point tells us really how much water is in the air. And then I can try to understand more how I'm going to deal with that. So sensible loads vary, but latent loads stay pretty uniform. So what we've got here is, again, from Ken Gehring here, we've got some data here that kind of shows us what's going on during the day. So when the temperatures are low, the humidity is high. And then as the day goes on, we get to 98 degrees and the humidity goes way down. But what's interesting is we've got the same dew point temperature going on, which is 71-degree dew point. That's a lot of moisture in the air. So just because the temperatures are changing and the RH is changing, we can't look at that as a gauge to really understand what the moisture content is. We really need to understand dew point. And this is one of the reasons that I think we need to look at more at smart ventilation and lockouts and how we're going to use that, because I'd much rather be ventilating with a 71-degree dew point at 98 degrees and have that air conditioner on helping remove some of that moisture than the air conditioner not running and loading up the house and then solely depending on a dehumidifier. So we're supposed to be supplemental dehumidification, but we do have a lot of builders in Texas that have gotten into some litigation issues, and now they size a dehumidifier for 100% of the latent load. So energy usage is a big one. This is a free ventilation electrical usage calculator on residential energy dynamics. I just put in the watts of our 98-pint dehumidifier, which does about 2,300 square feet. And I put in, I was going to use it 270 days of the year, and 20 minutes out of every hour in the day, that dehumidifier is going to run. Kilowatt of 11 cents. And you can put all these in yourself and it'll pump out. It was $159 to run that dehumidifier. So very energy efficient. So some key takeaways: tight energy efficient homes require less sensible conditioning, but the moisture loads are the same or increasing because we really are trapping in moisture now. Without a dehumidifier, there must be a sensible load for the AC to remove humidity. You have to have a temperature load for the AC to actually remove some of that humidity. And houses work till you put people in them. I run my HVAC system or the thermostat much differently than my husband does. And people want homes that are safe, healthy, durable, comfortable, and energy efficient all the time. And then I just put in my mentors here if we want to go into that quickly, or I can hold on.
The systems are phenomenal and they really make a lot of sense. You know, I live in a house that obviously is too humid and isn't a passive house yet, but the retrofit plan is now going to include an ultra air system. So I'm happy to kick that down the road. But I think it was a great presentation. And Trey, if you have an extra room when I'm in Texas, you know, I'll be happy to join you there. See some live bands. Last time I was in Texas at Austin, saw P-Funk and the Parliament Funkadelic. George Clinton and the Parliament Funkadelic on a Wednesday. It was great. But that's I'll kick it off to Sean. What are your thoughts?
Yeah, of course you had to go see some funk, my friend. Of course, always at the PH. No, great stuff. And I think, you know what, we need to stop and give these two a cheers. I know that they've, you know, needed a sip of something. So I just want to cheers to you guys. Great stuff, great information. And I can't wait to dive into the questions because I saw the chat going. So first, cheers.
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 All right, Shannon, let's dive into the questions. I know there's lots.
Great presentation, Nikki and Trey. That was really excellent. And we've got Ben Larson and Matthew in New Zealand and Tom Phillips to start us off. Ben Larson, are you out there and would you like to ask your question?
Yeah, sure. I was wondering, Trey, what the square footage of was your final result house, and how much did it cost to do it? And also, what was the trickiest detail you had to solve to try and do this?
So it was about 1,400 square feet originally, and it's 2,100 square feet conditioned now. So we added about 50% to the back. But that doesn't count, you know, over 200 square feet of front and rear screen porch, and then the loft. Overall, we came in at about $400 a square foot in terms of like final cost. But again, it's like with a retrofit, with a bunch of square footage is not accounted for that, and landscaping and all that. So it's how to come up with the exact price per square foot. And as far as the trickiest detailing, like I think we were trying to save a lot more of the building than we were actually able to. And so in hindsight, I think we would have rather like just scraped it and started over and just rebuilt in place. The front porch was really the only thing we actually ended up keeping just because all the existing framing was like balloon framed with no headers or support studs, and it just wasn't up to code. It was termite eaten, and so tying in a 100-year-old front porch that's leaning on a new construction passive house makes for some really interesting air sealing details that were super fun to execute. So I'm going to go with that.
That's a great description, Trey. That would be a tie-in to look at in a detail that's often drawn after the fact.
Yeah, or not drawn at all.
Right.
Thanks, Trey. And Matthew said he had more rhetorical questions, but I'm going to ask one of his because I thought it was great. He said, I'm wondering how many people who are selling ventilation systems know all this and are as good at communicating it as Nikki is. And what does that mean for what exactly gets specified and installed in most homes? Pretty good question.
Yeah, it is very challenging. I would say that more and more we are having ventilation manufacturers reach out to us because their builders are concerned that, well, not only do we have to say that we're providing ventilation, but oh crap, someone's going to measure it and actually verify that we're actually doing it. So that means it's actually got to be turned on. And so they are concerned now about the moisture that is being, and I'm in the Washington D.C. area on the Virginian side, but Maryland's on 2018 code. They're building some pretty tight homes by code alone, requiring ventilation, and they're on the coast. And most of the builders are using exhaust only ventilation because it's the cheapest. And then I get the calls to try to come in and fix it. And then they realize it really wasn't the cheapest because now they got remediation and unhappy homeowners. So I think there's definitely a tide changing more and more. And I think, when he talks about ventilation, if we look at the last year and everything that we've heard with COVID, it's ventilation, ventilation. We need more ventilation. Well, you can't just throw ventilation out there without thinking about all of what else is going to happen in that house or in that building as soon as you bring in more humid air. There's got to be more thought put into it. But as homeowners, I think you just think, what can I control? Oh, I can go from a 50 CFM bath fan to a 100 CF bath fan. Done. And they don't think about what the repercussions are going to be.
On this program, Nikki, a lot of people have requested we make custom shirts called Air Boss. And one of the lines you just said was, we can't throw ventilation out there. So we might need to create a ventilation boss shirt and we throw ventilation in there.
In there. And then you better throw some dehumidification as well while you're at it.
Yeah, for sure. From the get-go.
From the get-go.
Exactly.
It's interesting, like when we were getting started out, our contractors were like, oh, we just met with a rep for a VRF and it dehumidifies. And I was like, yeah, we'll see, and knowing Nikki and having positive energy on the team and even some of the, people at Mitsubishi who will, the sales reps say that that'll dehumidify, but when you talk to the people on the building science side, they're like, no, you need a dehumidifier if you're, especially in a low load home in a humid climate. It's just, there's nothing else to do.
And Mitsubishi's high performance team has been unbelievable. They brought us in, we do so much training with them, and they send so many builders our way because they know that there's going to be issues with the water removal in these low load homes.
Sounds like we need a moisture boss too.
Yeah. Can I just tell the story? Nikki alluded to a little bit about what she was helping us out. That was actually the rental property we were in while we were building this. Was a 2-year-old home, production builder in an area of town that's got a sort of above code green building metric on top of the code. And so as a middle unit of a triplex, it's a very low load home for a sort of production builder home. And about a month after we moved in, I went and, we had a bunch of books on a shelf and they were all kind of wet and slimy. And it took a while to figure out, but we had one of those like crystal rock sort of night lights that hadn't been plugged in, and it had started melting and was dripping saline sort of goo onto the books underneath it. And so, you know, I finally plugged in all the indoor air quality monitors that we kind of geek out on, and we were at like 78% relative humidity as an average. And so that was when I called Nikki, and she sent me our DHU about 6 months before we were ready to put it into this house. And it's just like, you know, I don't understand how those guys aren't dealing with all sorts of litigation on those homes. You know, that was, we were just paying attention to it and had the, you know, the metrics and the knowledge to pay attention to humidity. It's out there.
Moisture is the #1 detriment to a home. I mean, whether it's bulk or you know, vapor, or, and then also to health. So it is one of those things that I'm surprised. And I mean, we invented these in the mid 90s, so it's been slow going. And you know, as Ken Gehring, the man who invented these, had said, you know, especially with Passive House being more accepted and being accelerated more and more, that, you know, to him all the planets are aligning, because he's 81 years old. And so who would have thought? But I remember when I started with Thermostor, I had sent one of our engineers information on Passive House, and I'm like, I think this is something we should really focus on and learn more about. He's like, oh, that's such a small niche that those people are, nothing's going to become of that. And, you know, so after today, when this is recorded, I am sending it to him.
In fact, Nikki, you could give everyone on here his email address and have everyone send the presentation.
There we go. There we go.
I'll send it twice, double time.
I have the email still. I found it the other day when I was looking for some stuff. I'm like, oh, so short-sighted.
I think it's time to pull up another question. Let's see, who do we have next? How about Tom Phillips? Are you still here with us, Tom?
Yeah, thanks for the great show and tell. I'd love to come visit. Which neighborhood is that? Number one. Number two, in terms of climate readiness and resilience, I'm guessing you're going to see a lot more hot and humid days and worse days down there, not to mention power outages. But have you had a chance to do some overheating assessment for future climates? And just a quick note on humidity, I'm really glad to see you addressing cooking moisture and all the other sources, because Passive House people seem to be dragging their feet on this. But when I was asking the Energy Commission people here in California about some of these issues, and we do get some humidity problems in California, and we expect to see some more. They said, well, our standards only are based on dry bulb. Yeah. And we don't have any kind of moisture requirement, even though ASHRAE does. By reference to 62 ventilation standard, it references the 55 humidity standard. I mean, well, I take that back. That's thermal comfort. But in any case, the point is that I was aghast and pissed off because, you know, we've known for decades that moisture is a problem in tighter homes, and we've gotten a lot tighter for quite a while now. So anyway, I'm glad to see you're working on these things.
Sure thing. So actually, can I share the screen?
Sure.
I don't know if I can steal it. Nikki, do you mind?
So just quickly while he's pulling that up, my favorite project I ever did was in Dom DeLuise's house in Pacific Palisades. And ASHRAE is working on a committee is addressing of, well, let's talk about moisture according in ventilation strategies according to climate zones. So, you know, maybe in Florida, exhaust only shouldn't be an option to meet your ASHRAE 62. And start talking about that more in terms of ventilation. So
you know, yeah, I agree. I mean, I think this is, I don't know, everybody here is like buying batteries up and installing plants that can survive in New Hampshire, but I think this is probably a one-off event, or not going to happen in the next few years. But you're right. You know, passive survivability here and sort of like rolling blackouts, our peak load conditions are always in July and August in the afternoon. So we've been working with a team of researchers at UT who've been tracking a number of things in the house. It fell off a little bit because of COVID, and they can't access some of their lab stuff at UT. But we did do some studies pre-occupancy. So this is actually a summer load condition. And these are in a code-built research house that UT owns, are these three, the black, blue, and red lines here. And then these are in our house. And so this was when our house didn't have power in it. So this isn't exactly like a perfect scenario, but you can see like the cycles here are pretty tight. You know, we've got, you know, sort of like a 5-degree band that we're moving with the heat. And this is the AC turning on, turning off, turning on, turning off here. They turn it off. You can watch within like the first 12 hours, they're already experiencing, you know, heat higher than our house. And then the second day, just you can see the swings are just significantly higher. So we're definitely going to try and do some more research on this once, you know, we're able to, everyone's vaccinated, we're able to get them back in the home, set up some more data loggers, and we can go on vacation and see what the house does. But you know, this, and then sort of there hasn't been a ton of research done on this side. There's a lot of, you know, case studies coming out of northern climates for passive survivability with passive houses in cold climates, which our house definitely is another good data point of. And you can see that article that was posted in the comments about sort of how that behaved. But in a summer climate, it really seems to do the same thing. Yeah, I think one interesting thing with that we ran into was the CO2, where it was like, we were getting, so this was the second night in our bedroom, we were up at 3,200, you know, ppm of CO2. The first night was like a little spike at like 1,500. The rest of the house was not anywhere close to this, you know, and this is still well below the ocean, you know, limit, which is 5,000 just for as like a limit of concern. So it's definitely not super, you're not going to sleep well when you're up at this level, but it's not a health concern from a long-term standpoint. But it was, you know, it's still a little scary, and it's like, okay, do I want to open my doors and let in a bunch of fresh air, or you know, and drop the temperature of the house more, or you know, have a really stuffy house. And I think compared to my neighbors whose houses had burst pipes and it was, you know, 36 the first morning and well below freezing the second night, I think they would choose a stuffy house over one where the pipes are bursting and it's below freezing. But it's still, you know, kind of an interesting thing, especially as we look at like, okay, if we do get battery backup, maybe we hook it up to the ERV, you know, and have that run periodically, and then have the heat pump run periodically.
Right, just a quick question from the chat. Which app or monitoring system are you using there?
This is with AirThings. So we have, this was their battery powered, which is really nice. So they kept monitoring throughout the whole, it's like a, you know, a little watch battery that runs for you. But it's, yeah, AirThings Wave Plus is where these are coming from. We also have a Air Visual Pro from iCare that we got with them that has, you know, similar data and kind of a nice back end API. But I like the visualization that the AirThings provides.
Awesome. I had a Net Optimo a few years ago. I enjoyed it. It was,
yeah, it's been fun. You know, that like this a few years ago, there were like just a few options on the market, and now there's like all sorts of great stuff on these. These guys were primarily a radon, you know, focused company, but now they moved into IAQ.
On that same note, Trey, I was wondering how many of the graphics for the mechanicals did you do versus were done by someone else on the team, and especially like the 3D mechanical diagram there. Yeah, I'm loving that.
Yeah, so this is actually done by Positive Energy. They are doing all their work in Revit as a way to then they can do crash detection. If you can get a structural engineer for a house that'll work in Revit, which I haven't been able to, but it's still I can put it into my model, and then I can model the engineer, you know, most of the, or at least like the big critical structure, and just make sure that we don't have any conflicts. But it's really, you know, it's a really fun like visualization tool, just to see it.
Yeah, mine didn't look like that. We're almost near the top of the hour. We have a couple more spaces for questions, and we have Scott Kennedy up next.
A very quick question. I think most of the rest of it was answered in the chat, but I was wondering how the energy use of a dehumidifier compares to the energy use of an air conditioning system. And you know, I live fortunately in Vancouver, where we really don't have a humidity problem ever. But I'm curious about that.
Sure. So our dehumidifiers are extremely energy efficient. So let's just take our 70 pint that Trey has, it's 5 amps. So using 5 amps to try to remove moisture versus using the variable speed, which variable speed can, go down to, it can be at 20 to 30 amps all the way down to, I don't know, 6 to 8 amps potentially. But the dehumidifier will solely focus on removing moisture versus producing cooling. And you're only getting a third of that focus on the latent removal. So, it really is the most energy efficient way to solely control that relative humidity.
Great presentation, by the way. Really enjoyed it.
Thank you. I don't know, Trey, have you done any monitoring of systems running or anything like that in your house?
I haven't. We talked about it yesterday, and I reached out to Christoph about it, and he was like, "Yes, we can do that. Let's get on it." So, yeah, like part of that is like, part of with the UT research is just like that kind of all fell off the boards until with COVID right now, just not, people not wanting to come into a house and us not wanting to have people in a house. But yeah, we definitely are planning on, continuing to really study how this whole machine works and the data.
Well, one of the things that I shared yesterday as we were kind of talking about this as well, and that I always have in my presentation is a comment from Joe Steenbrook from Building Science Corp. And I was at the Passive House conference here in DC, and he was doing a full day session and was recommending in certain climate zones you're going to need dehumidifiers. And, somebody raised their hand and were like, wait a minute, whoa, you're telling us we're going to make these houses super tight and reduce the mechanical runtime, but now we have to put in a dehumidifier. And his response is 10 steps forward, 1 step back, and you cannot energy conserve your way to dry. And I think that goes with ventilation as well. To me, you ventilate when people are home to provide indoor air quality. It shouldn't be an energy efficiency strategy. Yes, can we do it more energy efficiently? Sure, but you shouldn't be blocking out times because you don't want to deal with the conditions that you're bringing in. If people are home, you should be ventilating.
And on that, I saw one of the, just jump ahead, one of the questions was about, do you really need to dehumidify if you have an ERV? Isn't that doing it? And I think that's a kind of common misconception about ERVs, is that it's doing a good job of not just opening a hole in the house and keeping the moisture out, but they're still bringing moisture in, and then there's all the moisture that's being created in the house, and so really it's not removing latent load, it's just helping reduce the amount of added latent load you're bringing in with your ventilation air. So you're not dehumidifying. Yeah.
It will always add to it. It'll just reduce it. And that's why, people like, oh, my ERV is a dehumidifier. Well, show me the drain. And,
exactly.
And if they show me a drain, that means it's because the core is going to freeze in the winter time and it's an HRV. And then it's got to defrost and the water's got to go somewhere. But yeah, an ERV will reduce the load. And Matt Reisinger, I think you have some videos there. Matt's been using us. I found him 12 years ago posting videos on ultra air dehumidifiers when he was just starting out. I'm like, who is this guy? But he will say that the Cadillac system, and I had this in Florida today, looking at some plans, super tight house. The mechanical engineer said, well, I'm just going to put in ventilating dehumidifiers and just use you for ventilation. And it was pretty clear to me that the budget, there wasn't really a budget, that, these people were pretty open to providing they wanted the best system. And the Cadillac is an ERV and a dehumidifier if people can afford it. It will reduce the load and just let the dehumidifier focus on the entire home. But if that's not the case, then use the dehumidifier for your ventilation and also for dehumidification.
Thank you, Nikki. So as we wrap up the hour, I'd like to give both you and Trey a chance to share a story and acknowledge a mentor in your career. Um, looks like your screens are up. So would you like to do it first, Trey?
Sure. So I was going to talk a little bit about this is Keith Simon. He's an architect here locally and a building science expert. He got me into Passive House. He kind of introduced me as his wife is a family friend, and when I moved to Austin for grad school, he showed me around and just became a fast friend, and he helped a lot on the house. This was a big, scary experiment for for me, in a lot of ways, and he was helped metaphorically snuggle me to bed at night when I was up freaked out that my window detailing was going to leak, or I was, any sort of anything from a building science standpoint. So it's just a great guy. He works for BES Terracon and does commercial waterproofing consultant, and is a great mentor and educator and leader in the field.
That's terrific. These are the stories that we need to hear about. Thank you, Trey.
Okay, so I'm going to slip in two. So the first one is Ken Gehring. If you don't know Ken, which I'm sure a lot of you don't, because he always seems to have been an innovator and far ahead of his time, and consultants on so many things, ACA manuals and moisture issues with Joe Steenbrick from years ago, fixing the one of the owners of Toyota on his house in Hawaii. So, but he truly is a mentor. He's on HVAC Talk, and he's known as Teddy Bear. And he's 81 years old. He invented these dehumidifiers. He put them in the back of his car, threw in his golf clubs, hit the road, and started going out and talking to the industry. And so if you see anybody who has a whole house dehumidifier, any of our competitors, it's because this man created the whole market and technology for it. I was on HVAC Talk today, and if I put in Teddy Bear, there are 18 pages of posts that he has on there that just goes back to 2018. And this man has been on that forum since it probably started. But the greatest thing is, he will tell you when a dehumidifier is not the answer. So he'll tell you what you need to fix and what you need to know and what you need to think about before you add a dehumidifier. And I've added recently to my presentations, because I think it's one of the best things is, and I'm going to get a tiara. I don't care what my husband says, I'm getting a tiara, but every king needs a queen. And this was just perfect about a description on how, the AC is king. We're not telling you that the AC can't do it. We're saying set it up right, make it do its job. But when there is no need for sensible, then the dehumidifier works, and that's the queen. And then my second one is Chris Conway, who owns Conway Energy here in the DC area, really was my introduction to multifamily needs. And because all the HVAC systems are extremely oversized when it comes to multifamily. So he's a Passive House rater, verifier, and consultant, and actually was the rater on the first multifamily Passive House renovation in DC. And not only is he my mentor, but he's also my husband. And 2 years ago this month, we actually got married. So very, very lucky, but you can imagine the building science talks in our house nonstop. And then, I've been very lucky. I've known Christoph from Positive Energy for probably 10 years, and, have learned so much from Positive Energy there in Austin. So I've been very lucky to be accepted into this community and be able to tap into a lot of resources. So.
Well, you clean up nicely there, Nikki. Yeah, I would say if Robert Redford, Scorsese, Ron Howard, if you're out there and you want to do a movie about Ken, that's what our airwaves need to see. So,
yeah,
Zach. Over to you, sir.
All right, thank you. And thanks, Nikki and Trey, for a fantastic presentation tonight, and also for sharing your mentors. That was really, really great. So we're going to say a couple, I'll share a couple of announcements about upcoming events. But first, I want to thank the organizations and companies that are making all of this possible, that make Construction Tech possible, and all of our other programming. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, StoCorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Aero Barrier, BR Plus A Consulting Engineers, Brennan Insulation and Airtightness, Inotech Windows and Doors, and US Engineered Wood Teasted. And I mentioned before, our sponsor of the week this week is StoCorp, our founding sponsor, and they are providing special support this week for all of the programs that you're seeing, that you have the opportunity to witness at the Accelerator. One of those is the podcast episode that is currently live with Beverly Craig from Massachusetts Clean Energy Center. I had a chance to sit down with Beverly and talk with her about her work accelerating uptake of Passive House in Massachusetts. There's really some amazing stuff happening thanks to her work and the work of others. So lots of policy moves to replicate, and she's also helping with planning the policy summit that I'll say a couple words about. Anyway, please check out that episode, really fantastic. Tomorrow we have perspectives from Spain around retrofits and airtightness and moisture control. So a continuation of some of the themes that we're hearing tonight from Oliver Style. So he'll be talking about a retrofit project and lessons learned and wisdom applied for a project in Barcelona. Next week on Construction Tech, we have Bob Kelly of Wickwright, who will be talking about Chicago's condensation crisis. That's very dramatic. And then we have the Policy Summit, the Passive House Policy Summit on Monday, April 26th. It will take lessons from Massachusetts, from New York, from Connecticut, from Washington State, from British Columbia, lots of exciting policy leaders who are going to be presenting on that. And I will share a link to it in chat right now. So that's it for me. Thanks everyone for being here. I'll hand it back off.